Hello friends, in this session we are going to discuss about an algorithm to find next smaller element. As per the problem statement, you will be given an integer array. The array contains only positive integers. It is not a sorted array. All we need to do is find the next smaller element for each element in the array. When we say next element, it must be on the right side of the element, not on the left side. Just print it on the console. We don't need to return the values back. In case if there is no smaller element exists for the given array element, then consider -1 as its smaller number on its right side. Let's say this is our input array. We will find next smaller element for each array element. For 6, the next smaller element is 4. For 4, 8 is greater than 4, so it cannot be. So for 4, 2 is the next smaller number. Even for 8, 2 is the next smaller number. For 2, 1 is the next smaller number. For 1, there is no smaller number exists, so we will consider -1. For 4 also there is no next smaller number exists, so we will consider -1 also here. For 9, it is 5. 5 is at the end. There are no further elements, so we will consider -1 here also. So these are the expected answers for each element. Let's discuss about the logic. The simplest approach is brute force way. We can use two loops. The outer loop is to iterate over the array, and the inner loop will be used to identify next smaller number. So the time complexity in this case is big O of n square in worst cases. But this is not an optimal way. Then what is the optimal solution? Can we get a solution with big O of n time complexity? Yes, we can using a stack. Here are the steps. We need to take a stack and maintain the elements in the increasing order in the stack. Now iterate over the array and follow below steps in each iteration. As a first step, check if the stack is empty or not. In case stack is empty, then push the element into the stack and continue with next iteration. Compare the current element with top of the stack element. Push it to the stack if it is greater than the top element. Since we are maintaining increasing stack order, we need to push it into the stack only if the current element is greater than top of the element. In case the current element is not greater than the top element, then pop it from the stack if it is less than the top element. The current index array element is the next smaller number for the popped out element. Now we need to continue this logic, popping out elements until the top element is smaller than the current element or the stack must be empty. Either these two cases must occur. So this is our logic. Let's apply this logic on this array. Here is our stack. Remember that we need to maintain elements in increasing order in this stack. In the first iteration, the number is 6. Since the stack is empty, push it to the stack. Number 6 is pushed to the stack. In the next iteration, the number is 4. We will compare 4 with top of the element. 4 is less than 6, so we cannot push it as we need to maintain the stack in increasing order. Pop the element out. 6 is popped out. 4 became the next smaller element for number 6. Since stack is empty, push 4 into the stack before going to the next iteration. In the next iteration, the number is 8. 8 is greater than 4, so push it into the stack. In the next iteration, the number is 2. 2 is smaller than 8, so pop out 8. 2 became next smaller number for 8. Continue comparing with next top element. 2 is still less than 4, so pop it out. 2 is also next smaller element for number 4. Since stack is empty, push 2 into the stack. In the next iteration, 1 is the number. 1 is less than 2, pop out 2. 1 is next smaller number for number 2. Since stack is empty, push 1 into the stack. In the next iteration, 4 is the number. 4 is greater than 1, so push it into the stack. In the next iteration, 9 is the number. 9 is greater than 4, so push it into the stack. In the next iteration, 5 is the number. 5 is smaller than 9, so pop it out. That means 5 is 9's next smaller number. And compare once again. 5 is greater than 4, so add it into the stack. So now we are done with iterations. There are no more elements left in the array. The leftover elements in the stack does not have any smaller numbers next to them. So consider -1 for these numbers. For 5, it is -1. For 4, it is -1. For 1, it is -1. So this is our logic, and it is exactly matching with our initial explanation. Since it requires only one traversal, the time complexity is big O of n. Now let's write the code. We have already created a static method called print next smaller element. It takes an integer array as an input. Now let's declare a stack. Iterate over the array. We will use for loop. Check if stack is empty. Push the element into the stack if it is empty and continue with next iteration. If stack is not empty, compare it with stack top element. If the top element is greater than the current element, then pop it out. We will use while loop as we need to constantly compare and pop out elements. Pop element and print it onto the console. Now push the current element into the stack so that we can find next smaller element for it in the next iteration. Finally, if any element is left over in the stack, then consider -1 as a next smaller element. I will copy this line and just replace it with -1 here. So this is our code. Let's test it. I have already written the main method and I'll uncomment this piece of code first. Here is our input array and we are calling the method with this input. Let's run. Here is the output and it is as expected. If you notice here, the output is not matching with array order. In order to return array order while printing onto the console, then better use a hash map. So this is about finding next smaller element in the given integer array. Hope you like it. Please like the video and do subscribe to the channel. Thank you.